Imagine surviving in a place where water is almost non-existent. No rivers, no lakes, just heat, sand, and extreme dehydration. Yet somehow, desert predators thrive and survive. The fennec fox, scientifically known as the Vulpes zerda, and the coyotes, the Canis lantrans, to explore how their renal physiology enables them to survive in extreme arid environments.
Let's begin with the fennec fox, the smallest canid in the world. Native to the Sahara Desert, you may recognize it by its oversized ears, which helps them in releasing heat. What you don't see is even more impressive. It's their kidneys. The fennec fox has relatively large kidneys for its body size. It also has an extremely thick renal medulla. It also has very long loops of Henle.
So now, let's compare this to the coyote. Coyote live in a variety of habitats, including North American deserts. While not as specialized as a fennec fox, their kidneys are still highly efficient. They possess moderately long loops of Henle, a well-developed renal medulla, and also a strong hormonal regulation of water balance.
Now let's zoom in way into the microscopic level, the nephron. The nephron is the functional unit of the kidney. So every kidney, it contains thousands of them. And each nephron, they perform 4 major processes like filtration, reabsorption, secretion, and excretion.
Okay, Heidi, let's break it down step by step. First step is the filtration.
Radio! So, blood enters a structure called the glomerulus. Here, water, salts, and waste products are filtered into the Bowman's capsule, and think of it as the kidney's first screening process.
But here's the thing. Filtration alone would make animals lose too much water. So the real magic happens next, which is the reabsorption.
Exactly! In the proximal tubule, valuable substances like glucose, amino acids, electrolytes, and a large amount of water are reabsorbed back into the bloodstream. Both the fennec fox and the coyote maximizes this process to prevent unnecessary water loss.
Now here comes the superstar of the desert survival, the loop of Henle.
This is where things get serious. The descending limb allows water to leave. The ascending limb pumps salts out but does not allow water to follow.
And that difference creates something powerful, an osmotic gradient in the renal medulla. This is called the countercurrent multiplier system. It's basically a concentration engine.
And now, here's where the comparison gets exciting. The fennec fox has extremely long loop of Henle and a very thick medulla. That means it can produce extremely concentrated urine. Almost no water is wasted.
Meanwhile, the coyote has moderately long loops. Still efficient, still impressive, but not as extreme as the fennec fox. The length of loop of Henle is directly proportional to a mammal's ability to concentrate urine. So a longer loop conserves more water.
Oh, and we're not done yet. Final stop, the distal tubule and collecting duct.
This is where hormones take control. When the animal is dehydrated, antidiuretic hormone or ADH increases.
So, what did we learn? Desert predators survive through extreme renal efficiency. The nephron, especially the loop of Henle, is the key adaptation. The fennec fox shows more specialized desert adaptations, and the coyote shows flexible but effective adaptations.
In conclusion, while we often admire desert animals for their physical traits, their greatest survival tool may actually be microscopic, which are hidden deep inside their kidneys. Without their remarkable renal physiology, survival in the desert would be impossible. Thank you for listening.